right, in physics, we're going to have a number of situations where we're going to deal with two equations, two unknowns. So we're going to start building our toolbox. And one of the first things we want to have in our toolbox is the quadratic equation. So let's take two equations. X is equal to 3 times t squared plus x is equal to 18t squared. And we're going to set these equal. So we've got it written out so we can set those equal. Now I'm going to do a bit of rearranging so I can put these in terms of our quadratic equation, where a is 3, b is minus 18, and c is minus 39. So we'll plug those into our quadratic equation, and we want a positive t, so we're going to solve for that. And then we can plug that back in and get our x. But now we're going to look at this in a situation of physics, and we're going to use our equations of motion. So I have a table here, and I'm going to have a baseball put on top of the table, and we're going to look at how the baseball rolls off the table. Now my table is going to be 1 meter, and my baseball is going to go off the edge of the table at 3 meters per second. So what we're really going to ponder on this situation is how far is this ball going to go? Now we do know we have an acceleration due to gravity, and we know the ball is going to fall something like this, but we want to know how far away from the table is the baseball going to land. And we want to have that answer. Well, guess what? It's a two equation, two unknown situation. We know that the initial velocity in both directions, x in the x direction is 3 meters per second, v in the y direction is 0, and motion is independent. So we're going to do our change in position and time. And because we know that initial velocity, we can solve this problem pretty quickly because we have all the information. So we'll solve for time. It's going to take the ball 0.452 seconds to fall. Now we can use the other motion to look at the x direction, but this time there's no acceleration. So all we're going to do is plug in time, and we have that initial velocity